Now see equation of continuity. Suppose you have taken a tube like this. In this, liquid is flowing in this way, flow is a streamline, and now this is the here area of cross section is here suppose A1 and area of cross section is here A2. Velocity of liquid is V1 and velocity of liquid is V2. So see here, flow is streamlined, liquid is non-viscous, and also the liquid is incompressible here. It means liquid is not collecting at any point inside the tube. Then in that case, whatever the liquid is entering into the tube, it means the mass of the liquid entering into the tube at this end is equal to mass of the liquid leaving the tube at this end. So the density of the tube is here rho, and here is also rho if the liquid is incompressible. So mass of the liquid entering into the tube is here, that we can write here volume. So A1 into V1 into density. So that is the mass of the liquid entering into the tube per second is equal to mass of the liquid leaving the tube per second. This and this will get cancelled here because the liquid I have taken incompressible here. So A1 V1 is equal to A2 V2, that means AV is equal to constant. Here A is inversely proportional to V. That means if the velocity is larger, area should be smaller. So at the smaller cross section area, velocity of the flow of liquid will be larger, and at the cross section where area is larger, velocity will be smaller.